And it's K8BYP with the last installment in the tube tester series. I've tested this 4-400 on the newly minted tube tester to test the tester. And determining the tester works, then this is the first test of a real tube by measuring power supply voltage, plate voltage, finding the current through the plate resistor, and measuring the grid voltage resulting in those readings. Just fairly simple data. And the point of that data is to go to the so-called plate curves. This is for the Amperex 6775, but pretty much the same as other 4-400s. And the point of this test is to plot these data on this graph against these characteristic curves with the grid voltage and see if we get anything looking like a straight line. Little dots there. Those are a very crude attempt to plot the plate voltage by the plate current on this extremely hard to read graph, with the additional problem that the span between the lines isn't exactly linear. So the best fit I can get by pretty much guessing is that crude attempt at plotting those points. But notice those points generally make a kind of a straight line, except for this last point down here, which is pretty much idle. Two places we'd never operate a tube like this at idle were over here where the lines curve in the saturation region, because both are highly distorted. So notice those lines are, or those dots are kind of sorta kinda in a quasi-straight line. Well, for more accuracy, I took the measured data to a graphing program which graphs the test tube, the conditions of the test, including extremely accurate measurements of the filament resistance and the interelectrode capacitances, because those are indicated on the data sheet. And when I plot these data, different points of plate voltage and plate current increasing as it goes to the right. And then I have the software, that's the blue line, I have the software snap in a linear trend line, and we see that the data recorded are almost absolutely dead straight in line. The crosshatch error bars show the deviation from straight line. But what that suggests is that the tube will be extremely linear through that voltage range, and that's the goal. Over here, plotted the vertical axis of plate current so that other lines could be extended for other values. And the point of all that is that when designing an amplifier with this tube, that we plot in a range of linear responses across these plate curves. Now we find the grid voltage range that corresponds with that. And here, the values of grid voltage V sub C and plate resistance have been recorded that correlate with these values of plate current on this line here. And the initial goal to get a linear response is to make sure that the grid voltage keeps the plate in a range that's out of this curved area and out of down here by idle. And the rest of that information on how to set that tube and the biasing up is in the IMAC documentation. And when that's done, the amplifier's up and working, then the RF drive from the exciter, which determines the grid voltage, and the grid DC bias can be adjusted for the cleanest operation. But what this implies, what this straight line implies, is a plate resistance. Then that plate resistance becomes the input image resistance to the matching network between the tube and the antenna. So there is basically everything you could want to know about that tube, including the plate seal temperature, and tested to 287 watts at 350 milliamp for about 5 minutes. That's a brick on the key test. So this is an old broadcast pull tube from the AM radio station. The cold test on the filament showed two different cold readings, 38.5 and 70 milliohm. And that generally agrees with the fact that the filament has a partial open. Sometimes it works. Most of the time it works, sometimes it doesn't. So I can take the filament pins and touch them on these gold posts on this high precision meter, and I can get a filament resistance of 76.7 milliohms. Extreme accuracy. Then by setting it to capacitance and clear, I can measure the capacitance between, for example, the filament and the screen grid, just because they're handy, which is 14.6 picofarad. So, including exact thermocouple measurement of the temperature of the plate seal, this is absolutely everything you could want to know about this tube, except actually plugging it in an amplifier unit. And what that does is not test the tube, that tests the amplifier unit. So for tube test, cold and hot, that's about as good as it gets. So there it is. Now I just have to put the cabinet on the tube tester and do something about that horribly noisy fan, and it's good to go.